Okay, 7.3 is solving exponential equations. So we're taking a look at bases and exponents, and then either working to find out what would the base be or finding out what would the exponent be in a given situation. So example number 1 there says write each of these as an exponent. So if we want 64 to write it as an exponent with a base of 4. So that means I'm going to have 4 to the power of whatever that will give it 64. Well, 4 cubed is 64. 81 written as a base of 3 would be 3 to the power of 4. Because 3 multiplied by, or to itself 4 times gives you 81. 625 written with a base of 5 will be 5 to the power of 4. So that's pretty straightforward, nothing too difficult there. The next part says convert each of the following to the base indicated. So if we have 9 to the power of 2x and we want it to have a base of 3. So the first thing we need to do then is we have to take the base that we have and we have to put it to the base that they want it to be. So 9 is the same as 3 squared. And then that 9 was to the power of 2x. So this would be 3 to the power of, and using your power rules, when you have a power to a power, you multiply them. So this would be 3 to the power of 4x. So 125, we want to convert that to a base of 5. So 5 cubed will give us 125, but we still have this power of 2 minus x. So same thing, power to a power, you multiply them. So this becomes 5 to the power of 6 minus 3x. So all I've done is just distributed that 3 to both of those terms. 1 over 512 to the power of 3x, they want that to be a base of 2. So 2 to the power of what will give you 512. And you can do this on your calculators, or you can use, you have from one of the first units, you have the chart with the, I think it goes up to the 9th power or something like that. So 2 to the power of 9 is the equivalent of 512, but that is still to the power of 3x. So this would be the same as 1 over 2 to the power of 27x. Now because this asked it to write in a base of 2, then what we want to do is we want to flip it so that it's not a fraction, but just a base of 2. So in order to flip this, we would have to make our exponent negative. So this would be 2 to the power of negative 27x. 16 over 81 to the power of x plus 5, we want it to the base of 2 over 3. So 2 to the power of 4 gives us 16. 3 to the power of 4 gives us 81. And then these are to the power of x plus 5. So using our power rules, this would be 2 to the power of 4 times x plus 5, so 4x plus 20. And this power applies to the top and it applies to the bottom. So you have to remember to simplify it that way. So this becomes 3 to the power of 4x plus 20. Okay, next one. Exponential equations in this section can be solved using a simple property of exponent. So if ax is equal to ay, then, so what they're saying there is if you have the same bases, then you can drop the bases and just say then that your powers are equal to each other. So that's like saying a to the power of 4 is equal a to the power of y. Well then x, or your y value would be a 4 because they equal each other. So it says, simply put, if any equation has only two powers with the same bases, then the powers equal each other. Here's a simple example to illustrate this property. If I have 3 squared is equal to 3 to the power of x plus 1, then my bases are the same, so I can just drop them. So then I have 2 is equal to x plus 1. I subtract 1. 1 is equal to x. So let's try it for ones where we don't have the same base. So it's 2 steps to this then. Instead of just dropping and solving, or dropping the bases and solving, you have to have the same base, and then you can drop it and solve it. So this one is a base of 5, so that means we want to try to get this one to be a base of 5. So 5 to the power of 3x minus 2 stays. 125 is the same as 5 to the power of 3. So times 2x. So now my bases are the same. I can drop that. I have 3x minus 2 is equal to 6x. So now to solve, I'll have negative 2 is equal to 3x. If I bring my 3x over, divide by 3, negative 2/3 is equal to x. Excuse me, I got the hiccups. Example 2, so I have a base of 7, so I have to see if I can make 343 a base of 7. So 343 is the same as 7 cubed. So now I have the same basis, so I have x minus 2 is equal to 3. X is equal to, if I bring that over, 5. I seem to be missing a page here, or is it lower? Oh, sorry, I just have to move my paper, I guess. Here. Nope, still not there. Okay, I'll just put example 3 and 4 right beside here. Don't know where that went. So example 3 was 3 to the power of 5x minus 1. Oh, you're missing those two. Okay, sorry, I don't know, they must have got cut off on the page. So just fill them in on your page. 3 to the power of 5x minus 1 equals 81 to the power of 3x. So 3 is a base, and we can't do anything else to it. It's a prime base, so we'll leave it as 3 to the power of 5x minus 1. 81 is the same as 3 to the power of 4 times 3x. So now I can drop my 3's. So I have 5x minus 1 is equal to 12x. Bring over that negative, or that 5, so I'll subtract 5. Negative 1 is equal to 7x. Divide by 7. So negative 1 over 7 equals x. Example 4, I'll put here. 3x is equal to 27 to the square root of 3. So 3x is equal to 27 is the same as 3 to the power of 3, and the square root 3 is the same as 3 to the 1/2. Because remember, a power that is a fraction means that it's going to be a root, and whatever is in the denominator is whatever goes in the index there. So what I have then is 3x is equal to, and since these are both the same bases, then I'm multiplying two of them together. So my rule is for product of powers, where it's up on the board here, product of powers. When you have the same bases and you're multiplying together, then you add your exponents. So this becomes 3 to the power of 3 plus 1/2. So I can drop my bases now, and I have x is equal to 3.5. And you're done. And in your textbooks too, it shows you how to solve these using a graphing calculator. But the basics of it is just that you would enter the left side of the equation as one function, and then enter the right side of the equation as the other function, and then use the intersect to find out where they cross. And then whatever the x value is of the cross, then that's going to be your answer. Okay, 1 over 16 to the power of x is equal to 8 to the power of 5 minus x. Well, I need these to have the same base. And I can't square 16 and get I can't square 8 and get a 16. That would give me a 64. So then that means I have to look lower. So I have to see 4 is a factor of both of those, but 4 squared gets me 16, but 4 to the power, there isn't anything I can put in there to get 4 to the power equals 8. So that means I have to go lower. So my next choice is 2. Well, 1 over 16x is the same as 1 over 2 to the power of 4 to the power of x. 8 is the same as 2 cubed times 5 minus x. Now these still don't have the same base because this is a denominator. So 2 to the power of 4 is the same as 2 to the power of, or 1 over 2 to the power of 4 is the same as 2 to the negative 4 times x. And this is 2 to the power of 15 minus 3x. So now I can drop my bases. I have negative 4x is equal to 15 minus 3x. So if I bring my 3x over, I have negative x is equal to 15, so x is equal to negative 15. Number 6, 27 to the power of x minus 2 over 1 over 81 to the power of x plus 3. So again, you have to think, okay, what base do I have that goes into both 27 and 81? So this is where using those charts will come in handy, because you can find 27 and 81 in the answer part and then see where they are both under the same base. So in this case, if 27 will only show up under the 3, 81 will show up under 3 and 9. So they're common under the 3, so we'll use the base of 3. So this is the same as 3 cubed times x minus 2. 81 then is 3 over 4 times x plus 3. So again, I can't have a fraction, even though they both have bases of 3. One is in the denominator, so I have to do the flip for that. So this will be 3 to the power of 3x minus 6, and this will be 3 to the power of negative 4x. So I'm changing this into a negative 4 here in order to flip it up. So it would be negative 4x minus 12. So now I have the same bases. I can drop them. So I have 3x minus 6 is equal to negative 4x minus 12. So if I bring my 4x over, I'll have 3x plus 4x. So I get a 7x, and if I add my 6, this will be a plus 6. So that'll equal, whoops, negative 6. So if I divide my 7, x is equal to negative 6 over 7. So again, I'm just on the calculator. If you're doing this to solve, you'll have y1 is equal to the left equation. Your y2 is equal to your right equation. And then you hit graph. And then you want to do that second calc button. Second trace, which is calc, and then do the intersect, and I think intersect is number 5. And then you do the y1 equal, or x equals, and then you hit enter, and then you move your cursor over, hit enter again, enter, and then it'll say guess, and then you hit enter and get your answer. Okay, problem solving wise. says, if you invest $1,000 at 6.5% interest compounded monthly, how long will it take for the investment to double? So our simple interest formula is A is equal to, so A just stands for amount, is equal to the principal, whoops, I don't need a bracket there. The principal times 1 plus the interest times n, where n is the number of compound periods. So this is just your simple interest formula. So your A is your amount that you're going to end up with. Your P is the principal, so the amount you start with. I is your interest. And n is the number of compound payments, or number of compound periods. So some people get confused here because they'll say if it's a year, and if it's compounded bi-monthly, then that means it's once every 2 months. So instead of they'll put the number of, for n they'll put 12 because it's a year and it's 12 months, but it's the number of times that interest is actually applied. So in that case, if it's over the course of the year and it's compounded bi-monthly, then that means it's every 2 months, so then you'd only have 6 periods. Okay, so for this question, using your formula, you identify, okay, what are your your variables. So I don't know my A. Sorry, I do know my A, because it's saying if you invest $1,000, how long will it take for it to double? So the amount I want to end up with is $2,000. My principal was P. That's what I started with, was $1,000. It's told me my interest is 6.5% or 0.065. If I take it out of percent, so this is in percent. And n is how long is that going to take? That's what I don't know. So applying it into my formula, A is equal to P times 1 plus I times n. So my A is 2,000 is equal to my principal of 1,000 times 1 plus 0.065 to the power of n. So now I need to solve this. So the first thing I'm going to do is divide through my 1,000. So I have 2 is equal to 1.065n. So then what I need to do is find out, okay, how many times do I have to multiply 1.065 to itself to get my answer? And my answer in this case is 2. So there's 2 ways of doing this. And we, in one of our questions in the last section, I talked about that. You can use just trial and error. And on your calculator, you would just keep going 1.065 times 2, 1.065 times, and you can go bigger, like maybe try 15. And if it's so that you have somewhere in between to take a guess at. The other way to do it is on your graphing calculator. To do what you'll do is you can do it the same way as I did it up here, where you'll put y1 is equal to 2, and y2 is equal to 1.065, and then that would be to the power of x, and then do it that way. Or the other way you can do it is by putting into your y1, so I'll put the calculator way here. You'll put y1 is equal to 1.065 n minus 2. So I'm just doing it in one equation. Okay, and then you'll hit graph and it'll draw it for you. And just for your window, your x values you can try between, you know it's not going to be a negative because you can't have a negative amount of periods, but just to show on your graph, I would do your window, just to give you a little bit of an idea, would be from -2 and then because we don't know exactly how long this is going to take, you could put to 50. And that's going to be plenty. So this is for your x values. Your y values, the same thing. You can do from -5 to about 20. And that should be enough to see on there. So then what you're going to do on this one, because it's not going to be an intersection, we want to do second and then the trace, so that's that calc button. And then we do the 0. So we're trying to find then what are the zeros of this equation. And you'll have to move your cursor over and then hit enter till you get your answer. So in this case, the answer for this is n is equal to 11. So on your calculators, and I don't want to use the calculator that I have on here because it's not that Texas Instrument one, but try it on there just to see if you can get that answer. Because this, using on the calculator, whichever method you use, if you're going to do 2 equations or the 1 equation method, so this is 2 equation method up here. And this one here would be the 1 equation method. So the 2 equation method, you're doing the intersect, which I think is 5, and the 1 equation method, you're doing the 0, and I think 0 is 2 on there. I might have them mixed up. But this will save you, if you can do it on the calculator on your test, it's going to save you a lot of time. Because if you have, I mean, this one it only went up to 11, but you might have one that goes up to 120. And if you're sitting on your calculator figuring all that out, it's going to take a while. Okay, the next question says, the population of ants in a colony doubles every 5 weeks. If there are currently 50 ants, when will there be 1,000? Okay, so if we take a look at this, the formula we want to use, and you need to refer to in your textbook, but it's basically just a manipulation of our transformation formula for exponential functions. So what we're looking at here is n is equal to, and in our original equation that would have been a y, but n is equal to ac dt. So our original equation would have looked at y is equal to ac bx. Okay? So when we were doing transformations in section 7172, that would have been the original equation, but this one, just to manipulate it so it works for this problem, instead of using a y, we're going to use n because we want to find out the number of ants. And then our a, of course, is just going to be our amplitude on the graph. Our c value is the same as it was there. Our b is the power, but then also that's going to be what's affecting the curve. And then your t value is just like your x value, so it's going to be your, or b is affecting the shape of your graph too, and then your x is just your variable. So if we take a look at this then, from our equation, n is the number of ants. A is always the number you start with. B is how long it takes. So if you think about that, in the last section we did the question with the half-life of, I can't remember what that chemical was called. This is the same type of formula that we used for that. We're just changing the variables to suit this particular problem, but it's the same formula or the same equation. C is just our base. And T is our intervals. So how often does this happen? In the money question, it was the number of periods. in the questions that we looked at in the other section, it was how many times or how often did it, or how long did it take for that half-life to happen? So it was in so many year intervals. So T is just your time in intervals. So for this question, it was every 5 weeks. So if we take a look at this, our N is the number of ants we want. So we want to end up with 1,000. That is our amount that we want to have. The A value is how many did we start with? Well, for ants it was 50. In the question about the, what was it, what was in the, I can't think of the word, smoke detector. It was that chemical in the smoke detector, so the A value was, where did that start at? The AM241. So we're starting at 50 ants. Our base, so what is it that is what is the base that's having the power applied to it? So in this question it says the base of the population of ants in a colony doubles. So that means we're going 2 times something. Whatever it is, it's always going to be times 2 because we're doubling it every interval. So that means that our base value is a 2. And then our T value is what we're trying to find. And these are in 5-week intervals. So there's a couple of different ways of solving this one. One is using your calculator, and then the other way is going to be to solve it out. And I'm going to give you a chance on your calculator to see if you can get it, and then I'll solve it out for you. So I'm just going to pause here for a minute. Okay, so if I think of this using, whoops, sorry. Put my pen down and start again. Okay, so if I think of this using a chart here, if I had 0 intervals, so if I start here, so if I put in a 0 there, 2 to the power of 0 is just going to be 1, so I would have 50 ants. So that means I would be at my starting point. If I did 1 interval, then that means I'd have 2 to the power of 1, which is 2 times 50, so I would have, this would just be 50, whoops, times 2, or 100. My interval is 1, but I have to remember then that is 1 5-week period. If I did 2 intervals, that would be the same as 10 weeks, and that would mean I would have 50 times 2 squared, which would be 4 times 50, which would be, what does that equal? 4 times 5, so that would be 200, right? And then you would keep going on and on and on and on like that. So you have to remember when you're solving this, whatever value you get here for your T value, that is just your intervals, and your intervals are in 5-week periods. Okay? So on your graphing calculator, if you did it that way, either using the 1 equation or the 2 equation method, if you did the 1 equation method, this would be 50 times 2 to the power of x minus 1,000. And then do your 0 to find the answer, or the trace. Or if you're doing the intersect, you'd have y1 is 1,000 and y2 is 50 times 2 to the power of x. If you're going to solve this algebraically, this would be divided by 50. So you'd be left with 20 is equal to 2t. So then trial and error when you get that, about 4.3 would be your time in intervals. So if it's 4.3 is your time, then that means that you would have to figure out your intervals would be, or the length of time it takes would be 5 times your intervals of 4.3 intervals every 5 weeks would give you 21.5 weeks. So it would take 21.5 weeks for you to have 2,000 amps. Okay? So that the key thing to remember when you're doing these is, depending on the question, your time or the answer that you're going to get is in how many intervals you have. So if this was every 2 weeks, then we would have had it as 8.6 weeks. If this was every 10 weeks, then it would have taken 43 weeks. So that's just a little note for you to remember. So your questions on this that deal with this are on 364, number 1 to 5, and then 9 to 12. And then that's it for Chapter 7 work.